today's video, we're going to learn about set. Did you ever hear the word set, or do you know something about it?
Yes, I heard something about set. Set is just to arrange something.
Okay, so good. Now in today's class, we're going to learn about set collection. I told you that if I set collection in Python program, what did I mean? I told you that to look at it like a basket where it's going to contain all of our data. And data, look at it just like an object. Yes, it's also an object in programming. Look at it like an item where you can just throw into the basket. So set is also a collection, which means a basket where we can throw our item into it, or we say throw our data into it. So when we throw our data, set has its own way of organizing all those data into arrangeable way, or maybe in a scattered way. It depends on it. So what is set? Set is an order, is an ordered collection. It's an ordered collection of data. When you throw data into a set, it did not organize them, not just like a list. A list, when you throw a data into it, is going to organize it the way you put it. For example, if I put 1, 2, 3, so this is how list is going to take them. It's going to take them 1, 2, 3, the way you arrange them. But set, if I put 1, 2, 3, then maybe when I go back and look at it, maybe go and come back and look at it, I will see something like 2, 1, 3. And I go back and look at it, maybe I'm going to see 3, 1, 2. So it's not ordered. It's completely what? Scattered. Yes, it's unordered. This is the first thing you have to know about list. Then the second thing you have to know about list is unique. When we say it's unique, is it doesn't allow multiple elements into it. For example, in a list, we can put 1, 1, 2, 3, and 2 like this. It will work perfectly. We're all going to see all the elements. But in set, no. In set, we can only have a unique element. If I have 1, I will never have another 1. Do you understand?
Yes.
I will never have
It
another.
can't repeat itself.
Yes, not repeated. No duplicate, no double element.
No double A.
Yes, only unique. So this is the two
But can
things.
we have like double set? The way you read it like 1 to 3, and then you have another set 1 to 3.
Okay,
It can
you
work.
are okay. You mean cascading the sets? Now we have a big set.
No.
Then we have this second set. Have 1, 2, 3. Then I have another one.
It's like
1, 2, 3. Like this inside a big set. Then we have the same set. No, it will not allow. The moment it realizes that they are the same, it will remove the other one and use only one. So set is
but
unique.
in a list, you can create
Yes,
different of two lists like that. One with a
list we can.
you can create it back.
Yes, list is not unique. You can put any kind of element you want. Then the second thing about set is it doesn't have index. No index. We know that a list we have 0. Sorry, let's say I have elements 20, 30, 72, 83. The first one has an index of what? 0. Second one, 1, 2, 3. Where we can use those index to access the specific element. But in set, this is not how set works. In set, it's not possible. This is list. List has index for a specific element to access it. But in set, no. There is no index. You cannot look for a specific element. Do you understand? And then the fourth thing you have to know about set, we can use mathematical operation of set in it. All this and intersection, union and negation. You can use all this operation, this mathematical operation you know about set. If you know set in mathematics, so all this mathematical operation about set, you can also apply them here. So we learn all about it. So now let's see how are we going to create a set. So to create a set, since I said is our collection, we have to give it a name. Then let's say I'm going to create a set of ages of people. Then we say ages. So in this case, we know that for a fact, if we have a 15-year-old person inside this collection, we will never have another 15-year-old person. So to create a set, we have to use this curly bracket. This is how we create a set. Hmm? Yeah, this is how we create a set. Then after we create it, then we can start putting elements. So we know that in our collection, the main thing to learn about it is, number one is creating. How are we going to create it? Adding element, removing, updating, then reading, and that's all. These are the most important thing for us to know about our basket. How can we throw something into our basket which is set? How can we add something to it? Or how can we create the basket? How can we add something to it? How can we remove it? How can we update what we have already inside? And how can we remove element inside? So this is how we create our set. So how can we add element to the set? Then we can maybe you can put the element at the beginning. For example, the moment we create, then I will start saying we have 20 or 20, 30, 27, 38. Do you understand? 40, 50. That's putting the element at the beginning when I created the set. Then I can also use a method called add. I can say ages dot add. Then I put the element I want to add into the ages, and maybe I can say 42. Then it will. Hmm? Yes, this is a method. So usually a method has its name and parentheses. So this method called add is just like an action to take. So method just look at it as action, taking action. So what kind of action am I taking? It's called add. So what am I putting inside? 42. To what? To this basket. You understand? Then we also have what? This is how we add element to. Yes. Then for the removing, then we can see ages. Then it has two way of removing. We can three way. I mean, you can see ages dot remove. Then we put the element we want to remove, like I said 20. Then we have ages dot discard. Then we can put also the element we want to remove. We have 20. This one is going to remove 20, while this one is going to remove what? 27. Then we also have 4 ages dot 4. So you're going to randomly remove elements and you're going to tell us the element he removed. You can print the element, but this one will not tell us because we are the one put the element, and this one will not tell us. So this one and this one, they are also working the same, but why are we having remove and discard? The reason is that this one, if you don't have the element inside the collection, it's going to throw an error stopping your program. While this one, when you're about to remove an element and the element is not exist in the set, this one will not throw an error to you. It will continue. You just see a dash silent. And this one is going to just remove the last element and tell you what element did he remove.
Okay. But this one adding, is it adding at the beginning or at the end?
I told you it's not ordered. So you can't say it's going to add at the beginning, at the middle, or it's unordered. Just like you throw something into the basket, you can't say whether it's going to stop at the top or at the bottom.
So you suffer when you are looking for it.
Yes. So now, how can we update elements? And that's the main issue of set. We can't. If we throw element to it, that's all. We cannot update it. And can we read a specific element? No, we can only read the whole element. We can only say print. Then I set ages. Then he's going to show me all the ages, all this. But we cannot look for a specific element, and also we cannot update specific element. Do you understand?
Yes.
So this is all about sets. You can see add, remove, create, good. Updating, no. Reading, no. So any question? So about the mass operation of a set. Now let's have a two sets and see the, are you copying? Okay, so let me, okay, you're done. So let me have a two set. Let me call this one n1. Let's leave it as n1. Then it has 1 2 3 4 5 6 7 8. Then we have another set called n2. This n means number 1, number 2. Then we have a set of maybe going to say 5 5 comma 6 1 comma 3 9 10 11. So we can perform mathematical operation about these two sets. We have three mathematical operations. Oh, I said yes, 4. We have intersection, we have union, we have difference, then we have symmetric difference. So let's start with the first one, which is intersection. Intersection is like if I set n1 and I put dot, the right intersection, then I say intersection n2. So what I'm asking my computer is, what element do I have in set 1, n1, and also exists in set 2, which is n2? When we look at the set 1 and set 2, so which element do we have here that also exists here? So now we have
5,
we also have 1,
we have 6,
we have 6,
we have 5,
5,
we have 3.
we have 3, yes,
That's all.
that's all.
Those are 9.
So this is the element we're going to see. If we print this statement, this is the element you're going to see. You're going to see 1 6 5 3. Do you understand? That intersection is going to find the element that exists here and also exists here. Then union. What about union? When I say n1 union n2, so what I'm trying to say is just, you know the word unity, right? Unity, like coming together. So just like union, coming together. So it's going to like combine, it's going to combine this set and also this set. It's going to join them all together. So we're going to have a set like this. We're going to have a set from 1 2 3 4 5 6 7 8, right? Then we have 9 10 11. So it's going to combine them together. And when it combine them together, remember I told you that set is unique. So do you think, are we going to have double 1, double 3? We are not going to have them. Yes, they're going to also have only single 1, single 2, single 3.
We have 1 here, just people and discard 1.
Exactly. So this is union. Intersection, finding what's here and what's here. Union, combine them together and form a unique new set. Then moving on to differences, we're going to say set 1, which is n1 dot difference n2. What it's trying to do here is, what element do I have in n1, and what element I want to remove all the elements that are in n2 from n1 and see what is the remaining. Do you understand?
You want to remove all the elements.
Yes, element of n2 in n1, yes, and see what is the remaining. So if we have 5, so we're going to, we don't have 1, say 2.
You have 1.
Yes, that's why I did not put it. So we have 3, but we don't have 4, we don't have 6, right?
You have 6.
But we don't have 7
Yes.
and 8. So this is what we're going to see. After we remove all the elements of n2 from n1, this is what we're going to see at the remaining. So this is the differences. This is the difference. Do you understand? And also if I change it to say n2 dot difference n1. So it's like I'm saying remove all the element of n1 from n2 and see what's going to remain in n2. We're going to see yes 9, 10, 11 exactly. So this is also their what differences. So did you see, look at these differences? So the second one is going to help us with these differences. This is the difference when we remove the element of n2 in n1. This is what we're going to remain in n1, right? When we remove the element of n1 from n2, that's what we're going to remain in n2. So the symmetric difference is that all these remaining elements, so now have them a union, combine them together. Do you understand? This is the symmetric difference. The difference of n1 and to n2 and the difference of n2 to n1, all their differences, this one, can now combine them together. That's the symmetric difference. Have a union about them. I said, when you have the difference of n1, remove the element of n2 from n1. This is what is going to remain. And then we remove the element of n1 from n2. This is what's going to remain. So now we're going to combine them together. This is what we call symmetric difference. So at the end, we're going to have something like this. We're going to have 2, 4, 7, 8, and what? 9, 10, 11. So this is symmetric difference. Yes, exactly. So do you understand set collection? That's it, all about set. And there is a lot of other methods we can apply to set, like count, length, and so on and so forth. But I used to focus on, just since we are working with collection, those they are just fancy methods. We can do some calculation and other stuff with it. But these are the most important one: creating, adding, removing. So
the other one to go like this. Why are we going to use it?
Exactly, very good question. Since we have list, tuple, so what are we learning about set and why are we going to learn it? So if you look at closely, they have differences. List is ordered and have multiple elements, while set is not ordered and is a unique. So in some cases, there is a time come that you don't want to work with list because it's not going to fulfill your action. We're done with the theoretical aspect. Now we're going to set about the practical of this collection called set. So in the theory, we see the differences between set, tuple, and list, the differences between them, and while every one of them is unique and have its pros and cons and where to apply them based on what you want to create and what you want to store. So now in this practical aspect, I hope you have your computer next to you where I can write what I write, you understand what I write, so it's going to be easy for you. So we're going to create a collection where we're going to store ages of people, and we don't want that ages to be duplicate. If we have a 50-year-old age, we don't want him to have another 50-year-old person. We want only single 50-year-old person inside our set. Do you understand? So now I'm going to say, okay, we're going to call it ages, and ages. Then for you to create a set, you just have to use curly bracket. Then you put curly bracket. Okay, 21 year, 34, 65, and 60. So this is how we create a set. And now let me print the set so that you can see how it is. Say ages. So like I told you, set is unordered. It's not ordered collection of items. It's completely unordered. So you see, what do we have here? We have 56 second to the last. What do we have here? We have 56 at the beginning. Do you understand? So set is completely unordered. It's not going to show you the element the way you put them is no, it's going to scatter them around. Even if I reprint it, I can still see 56 at the beginning and so on, but deep down inside the memory space, it shows you the proof that it's not ordered. Do you understand? So now how can we add element to a set? Okay, let me leave this print so that whenever we make changes, we can be able to see. So let me say ages, then I said add, you see, then I say, let me say 22. So I add 22 age, 22-year-old. Then if I run it now, I'm able to see, you see, I have 22. Did you see it? And also, let me try to add the thing I already have, like 21. I already have 21, right? And now I'm adding 21. So what do we expect to see 21 double time, right? But instead, we are not going to see double time, only see it one time. You see, we only have 21 a single time. Do you understand? So this is how we add element to it. And now moving on to remove. So for us to remove is very simple. You just call your collection, which is age. Then we say dot. Then we tell him to remove. Then we say remove. So what do we want him to be removed? We want him to remove what?
56.
Let's say
56.
yes. Let's choose 56. Oh boy. So we want him to remove 56. And now if I run it, I'm going to see 56 has gone. Do you understand? And also together with discard. If I said discard, and also you are not going to see discard. You see, discard is being removed. And also we have pop. And like I say, pop is going to remove. We don't know the element pop is going to remove, but we can ask him what element did you remove. See? Okay. Sorry. Set the pop takes no argument. Okay, yes. I put 56. I forget pop doesn't take any argument. So if I run, you see, it also remove 56. What a look. So but like I told you, we can ask him what element did you remove. Let me print it. I can print to see the element it removed. If I run, see, it's telling me it removed what? 56. So we cannot predict the pop.
Add double pop.
No, we can't do that because this one is removed. It's returning 56, not a set.
Okay, no. If you add another pop under, it will remove
Okay.
another.
Yes, it's going to remove different item.
Yes.
So like this, if we say remove dot pop, you see now it remove what? It removes 16. But don't let set fool you thinking that no, it's just reversing the set and it's no. It's random. Just put that in your mind. If you have like thousands of elements, it will not act this way. Maybe it's because I have a very small amount of data, right? That's why it's acting. No, don't pull yourself with that. Do you understand? So now we learn about pop, and then discard, remove, and now what else do we need? We learn how to create, how to add, and how to remove.
Try to update.
How can we even have, if I say I'm going to access a specific element, I say 0, is going to give me an error because it cannot do that. You see, set object is not subscriptable. Yes, you cannot access a specific element. So if I can access a specific element, that's where I can say is equal to, then I say 29. That means updating. So I cannot access specific element. That's right.
Then you cannot update it.
Yes. So now let's learn about the mathematical operation of what? Of a set. So let's take out this and create that n1 equal to, then we put 1, 2, 3, 4, 5. Yes, let's leave it to 6. Then we have n2 is equal to 1, sorry, yes, 1, 3, 5, 7, 8, 9, 10, 11. So now we have two different sets. We can join them together. We can find what is inside here and also what inside here, which is intersection. So let's start with union. So I'm going to say print then n1, I will say n1. Let me put it at the beginning, then we can replace what inside. I will say n1 dot union. You see it? n1 dot what? Union. Then I said into. So it's going to take the element of n1 and combine it. So and like I said, n1 union n2. So it's going to combine the element of n1 and the element of n2, but it will not repeat. We have one here, we have one here, so we're only going to see one, only single one, I mean. So if I take this element, this statement, and print it to see the output, then you're going to see a new list. You see, this is a new list: 1 2 3 4 5 up to what, 11. So it's not going to duplicate or make the element to be double. Do you understand? Then after union, we also have another operation called intersection. So I can say n1 dot intersection n2. So n1 intersection n2. I want to ask question. Okay. Since we know that state is not is an order, and we need a union between n1 and n2, and the result appeared to be okay. This one. No, like I said, deep down into the memory is not order. So yes, it's scattered. Don't let this one fool you. Just remember that it's not ordered. That's all. So now intersection is going to take what element do we have here and what element do we have here. It's going to show us to them. We have one. Yes, one is going to exist because one intersected one here. We have 3, we have 5, and that's all. So if we take this statement and print the output, we're going to see the value that exists in n1 and also exists in n2. See them? 1 3 5. Then the second operation is what? Difference. If I say n1 dot difference n2, what I'm saying here is if I remove the element, the same element, if I remove element of n2 in n1, what is going to remain in n1? So let me run this, let me print the output of this statement and see. So you see, we only have 2 4 6 remain. Do you understand? We only have 2 4 6 remain. The difference, I said, let me repeat, I said, what do we have in n1? If we remove the elements of n2 in n1, what is it going to remain in n1? If we remove, we have 1. So if we remove 1, we have 3. If we remove 3, uh, we have 5. If we remove 5, then what is going to remain? So that's why it shows us 2 4 6. That's the only element that we remove and remain, I mean. Do you understand? Then we have symmetric difference. If I now switch, I said n2 dot difference n1. What I'm saying here is if we remove the element of n1 in n2, what is it going to remain? What is it going to remain in n2? So let's see. You see, this is the element. So now if you remember, this is the element that what remain if we remove the yes, if we remove the n1 element from n2, and this is the element to remain if we remove what n2 from n1. So now if we, what if we combine those elements, the differences of all of them? So that's what we call the symmetric difference. If I said symmetric difference, so it's like, okay, when I remove the element from n1 and n1 from n2, then what's the remaining, then let's combine them together. So it's just like combining this one and this one together. Do you understand? Well, if I run now, you're going to see the output like this. You see, 2 4 6 9 7 8 9. So that's what we call the symmetric difference of a set. Any question?
No.
No question. Do you understand? Yes.
Yes.
So that's all. See you in our next class.